Uh, just to know how to apply Venn diagrams in solving questions in probability, we will discuss the basic concept of Venn diagram. A Venn diagram is a diagram of sets showing two or more sets and classifying various members of sets according to their attributes. So we sort data according to the given two criteria or given two sets. Um, let's consider an example of 10 students. So we have 10 students here and we will sort them according to their hair color, brown color, whether a student has brown color or not, and whether he or she wears glasses. So there are two criteria. Number one, whether the student has brown hair, and the other criteria is whether he or she is wearing glasses or not. So first we will make a universal set. A universal set is the largest set which contains all the small sets, and then we are making a set of brown hair students. All the students who have brown hair will come inside the set, inside this set. And secondly, we have another set labeled glasses. All the students who wear glasses will come inside this set. And the students who have brown hair and glasses, they will come in both of the sets, and they will come in the overlapping part of the sets, which is in the middle. You can see where the two sets overlap each other. The first student doesn't have any brown hair and he doesn't wear glasses, so he's not going to enter any of the two sets, so we will keep him out. Next is a girl who has brown hair and she's not wearing glasses, so she has brown hair, so she will come in the set of brown hair. Okay, make her stand here. Next is a student who neither has brown hair nor he is wearing glasses, so he will not come in any of the two sets. We will make him stand outside of the two sets. Next is a girl who is wearing glasses. So she is a student who is wearing glasses. She should come in the set labeled glasses. So let's make a stand in the set. The next student has brown hair on his head and he is not wearing glasses. So he cannot come in the set labeled glasses, but he can come in the set labeled brown hair. So he will not come in the common part. He will come on the left portion of the brown hair set. Okay, next is a girl who does not have brown hair and she's not wearing glasses, so she is not going to come in any of the two sets. She will stay outside. Next is a student who is wearing glasses, but he does not have brown hair. He has black hair, so he will not come in the set of brown hair, but he can come in the set labeled glasses. So we will keep him stand on the right side of the set wearing labeled glasses. So on the right hand side, we will make him stand. We will not make him stand in the middle. All right. Next is a student who doesn't have brown hair and who is not wearing glasses. So he will come outside of the two sets. He will not come any of the two sets. Next is a student who has brown hair and he is wearing glasses. So he should come in the brown hair set and in the glasses set. So we will make make him stand in such a position that he is in the brown hair set and as well as in the glasses set. So he will come in both of the sets. That is, he will come in the overlapping part. So he will come in the middle of the two sets so that he is in present in both of the sets. Next is a girl who has brown hair but she's not wearing glasses, so she will come in the set of brown hair people. So we have arranged all the students according to their fact that they have brown hair or not, or they are wearing glasses or not glasses. Next. So this is a very basic way of arranging items. Uh, Practically, it is very lengthy, cumbersome to arrange the pictures. It's better to count the values. We do not write all the ways, we actually count the values. So let us denote the event B that a student has a brown hair, and let us suppose that event G is the event that a student is wearing glasses. Sorting all the students, we are now going to count the number of students in various regions of this universal set. We have different regions here. For example, the set B itself has two regions. The three students on the left side and one student on the right hand side. and each region has a different concept, different meaning, different classification. We will discuss them all one by one. First of all, we will draw again the universal set, and this baby sign denotes the universal set. It's a Greek letter. The letter B will denote the students who have brown hair, and the letter G will denote the students who wear glasses. Okay, we are putting a 1 in the common region. Why? Because there is only one student who is wearing glasses and who has brown hair. So he is coming in the common part. This is called the intersection of the two sets. So the number of elements or the number of students or number of items common to both of B and G is only 1. Now 3 here. The number of students who have brown hair but they are not wearing glasses are 3. They do have brown hair but they are not wearing glasses. And the total number of brown students is, you can see, 3 plus 1. We will count that also. 2. Why 2 here? Because there are 2 students who are wearing glasses but do not have brown hair, right? They have different color hair, different from brown, but they are wearing glasses, so there are 2 in number, such students. And 4 students, they are not in any of the 2 sets. That means they neither have brown hair nor they are wearing glasses, so they are 4 in number. So total number of students, we can calculate the total number of students or total number of elements or items by adding all of the numbers in various regions. So 4 plus 3 plus 1 plus 2 will give us a total number of elements in the universal set, which is 10 here. Okay, then to count the number of elements in the set B, we have to count the various number of elements in various regions, 3 and 1. There are 2 different regions, but we will combine them, we will add them to get the number of elements in the set B. So total number of students is down here, 3 plus 1, that makes 4. This is the number of elements of set B. And number of students wearing glasses, 1 plus 2 is equal to 3. This 3 is the total number of elements of the set G. That means total number of students wearing glasses is 3. There are 2 types of students who are wearing glasses. 2 do not have brown hair, 1 has brown hair. So that's why they are in 2 different regions, but they all are wearing glasses. Now, the students who have brown hair and they are wearing glasses, there is only one such student which lies in the common part, which is standing in the common part of the 2 sets, overlapping part, which is called intersection, and this is only 1. And the number of students who neither have brown hair nor they are wearing glasses, they cannot come in any of the 2 sets, so they will stay outside. And there are 4 such students who neither have brown hair and nor they are wearing any glasses. And if we want to count the students who have either brown hair or glasses, that means uh, they have any one characteristic. Either they have brown hair or either they are wearing glasses. Only one is characteristic is good. So we will count all the students who have brown hair, who are wearing glasses, and who have both brown hair and wearing glasses. So 3 plus 1 plus 2 plus is equal to 6. These 6 students have either brown hair or they are wearing glasses. Subset of a set. As the name suggests, a subset is a smaller part of a bigger set. So if every element of a smaller set is also the element of another bigger set, then we say that A is a subset of the bigger set B. For example, let us consider set A, which has elements 2, 4, and 6. Set B has elements 1, 2, 3, 4, 5, and 6. And set C has elements 0, 1, and 2. So what do we note here? That each element of set A, that is 2, 4, and 6, is contained in the bigger set B. So we can say that A is a subset of the bigger set B. And how we denote it? We use a mathematical symbol, a horizontal kind of U. This symbol will be used to denote that a set A is a subset of B, and we read it as is a subset of. And if we see the elements of set C, these are 0, 1, and 2. 0 is not contained in set A or set B, so we can say that each or every element of set C is not contained in A or B, so C is not the subset of any of these 2 sets. Okay, let's draw a Venn diagram for these 3 sets. Of these, the set B is the biggest set containing elements 1, 2, 3, 4, 5, and 6. Let's draw it. first, set B containing elements all from 1 to 6, and set A has elements 2, 4, 6. So since all of it has, of all of its elements are inside B, so all of this set will be inside B, and it will contain the elements 2, 4, and 6. And set C has elements 0, 1, 2. 0 is not contained in any of the sets A and B, so 0 will lie out of these two sets A and B, and 1 and 2 are common elements, so we will make the set C by overlapping its some region with A and with some B, and then some separate region which has element 0. There are two kinds of subsets, proper and improper subsets. An empty set is the subset of each and every set and the full set itself is also a subset of itself because it contains all of its elements. So these two sets are called as improper subsets. All of the subsets which are not improper and which always contain elements less than as compared to the original set are called as proper subsets. So we will discuss an example to show improper and proper subsets. Let us consider set A containing three elements A, B, and C. The set empty set and the set containing the elements B, A, and C. Only the order has been changed. Even if we don't change the order, we can say that this set is an improper subset of the given set A. So these two are the improper subsets because one is empty and the other is equal to the original given set. And all other subsets which we will make from this set, taking some of the elements of A, will be proper subset of A. When we take some of the elements of A, we will not take all the elements at a time, so we can miss one element or two elements and make subsets. For example, single elements A, B, C, and then double elements A, B, B, C, and A, C. These are all proper subsets of the set A. The intersection of two sets. The intersection of two sets is a set of elements which are contained in both of the sets. If we take all the elements which are in both of two given sets, we say that it is the intersection of the two given sets. For example, if we have sets A and B, then we will denote the intersection of these sets A and B by A intersection B, a symbol, inverted U, and it will contain the elements which are in both of A and B. Any element which is in intersection should be in both N and B. For example, if we have a set A 0, 2, 4, 6, 8, and 10, and set B 1, 2, 3, 4, 5, and 6, we see that the intersection of set A and set B is, we will note the common elements. 2 is contained in both of the elements, 4 is contained in both of the elements, and 6 is present in both of the sets. So these three elements, 2, 4, and 6, these are present in both of the sets A and B. So they will form the intersection of the sets A and B. Intersection of sets A and B is a new set which will contain the common elements. And we denote it by A intersection B. And we will write all the common elements. This inverted U sign is read as A intersection B. Let us make a Venn diagram for it. A contains elements 0, 2, 4, 6, and 8, and 10. And B contains elements 1, 2, 3, 4, 5, and 6. So we will make B in such a way that the common elements fall or lie in B and A both. And this overlapping part is called the intersection of set A and B. Let us shade this part to elaborate it. This shaded part is called the intersection of A and B, or A intersection B. Let us consider two more scenarios of intersection of two sets. It is quite possible that all of the elements of a set are contained in a bigger set, and that there is no element in the smaller set which is different from the elements of set B. In that case, the smaller set A is a subset of the bigger set, and we can say that A intersection B is equal to the smaller set A. And obviously the number of elements in the common part or the overlapping part or the number of common elements will be equal to the number of elements in the smaller set. Since all the elements of A are contained in the bigger set B, whole of the set A will lie inside the set B. So this is Venn diagram representing intersection B when A is a subset of B. To show the elements which belong to the intersection part, or to show the A intersection set here, we can shade the whole of the set A, which is actually the intersection of both of the sets. This is the common part of both of the sets, the overlapping region. And there is one more scenario when there is no common element between A and B. In that case, the intersection of A and B will be equal to empty set. Empty set is also denoted by symbol phi. And in this case, the number of elements in A intersection B is 0. And A and B are called disjoint sets because there is no common element. And how will we show the intersection? There is no intersection. The sets are not overlapping, so we cannot shade any region. So we will make them as separated sets. Now let us consider another concept of union of sets. By union we means combining elements of people. When people unite, they come together, they combine to form a single entity. So union sets is a new set which combines all the sets of the two or more sets. So the union of two sets contains elements which are in at least one of the two sets. Any element in one set will come in the union of the two sets because we are combining or uniting all the elements of the two sets. It is denoted by AUB. It's a U kind of a symbol similar to U, which denotes the union of A and B, which contains all the elements which are in either A or in B. Any element in A or B, these don't have to be the common elements. Any element in A will come in A union B, or any element in B will come in A union B. For example, if we have set A 0, 2, 4, 6, 8, 10 and set B 1, 2, 3, 4, 5, 6, then to find the union of these two sets, we will combine all these elements and we will not repeat any element and we will write them in order. So A union B denotes the union of these two sets, and we will combine all the elements and put them in order, and this symbol used read as A union B. Let us make a Venn diagram for this situation, for the union of two sets. So this is a set A containing the elements 0, 2, 4, 6, 8. This is the biggest set, and we have another set B which contains elements 1, 2, 3, 4, 5, 6, and we have some elements common. The common elements will come in the overlapping or the common part. The rest of the elements 1, 5, 3 will stay outside A, but they are inside B. Now, how will we show the union of these sets? We will show the union by shading. So all this shaded region shows the union of A and B. Let us consider two more scenarios of A union B. When one set is a subset of a bigger set, that is, all elements of a smaller set are contained in a bigger set B, then in that case A union B is equal to the bigger set B, because when you combine all elements will always be the elements of the bigger set, and the number of elements in the combined number of elements in union A union B will be equal to the number of elements in the bigger set B. You can see this clearly in the Venn diagram. B is a bigger set and it contains all elements of a smaller set A, so A will come inside A. So the number of elements in A union B is the number equal to the number of elements in the bigger set B. And to show A union B, we can shade all the region of B. So the shade region shows A union B, which is actually the whole of the set B. There is another scenario when there is no element common in A and B. And in that case, we say that A intersection B, or the common part, is empty set. We also denote this empty set by the symbol phi. And how we will make the Venn diagram for this? We will make them separated because there is no element in common. These are disjoint sets, and we still can combine the elements of A and B to form their union, to find their union set. So we will shade all the elements of A and B to find the union of these two sets, because any element of A will come in the union, or any element of B will come in the union. Let us consider some examples on intersection and union. First of all, we have a question number 1. Set T, X is an integer. Set T is a set of elements X, such that X is an integer between 5 and 8. We have to do parts A and B. So first we have to list the elements of set A. The elements are the integers between 5 and 8. So starting from 5, after 5 you have the integer 6, then you have 7, and then comes 8. So all the integers between 5 and 8 are just 6 and 7, only two integers, and we can easily state the number of elements in set A, which is just 2. Part B, we have to write all the proper and improper subsets of the set T, As we know that the empty set and the set itself are always the improper sets of any set, so we will write these two as the empty sets, as the subsets of the set T, first the empty set and then the full set T itself. This will come as an improper subset of T. So these are the two improper subsets of T, and next we will write the proper subset of T. Missing any one element, we can write the proper subset of T. So the set with only element 6 and the set with only element 7 are the proper subsets of the set T. Now let's do another question on these operations of intersection and union. If A is a set of alphabets of the word Mississippi, which is the state of United States, and B contains only one letter S, first of all we have to list the elements of A. Now A is the set of the alphabets of the word Mississippi. We have to write the letters of the word. We don't have to count the repetitions. We don't have to repeat the elements. Every element should come only once in the set. So we see that M is coming only once, but I is coming four times, S is coming four times, P is coming twice. We will not do this repetition in the set. We will write each letter once. So the letter, each letter will come once in the set A. So I, M, P, and S. These are the only four letters being used in the name of this state, Mississippi. So the number of elements in the set A is just 4. Then in B part, we have to state with the reason whether A is a subset of B or B is a subset of A. The smaller set, which is contained in a bigger set, is called the subset of that bigger set. You can see B being the smaller set, and all of its elements are contained in the bigger set A. B is a subset of A, not A is a subset of A. So we can state that B is a subset of A. In part C, is A intersection B is equal to B? Give reason. Since all of the small set B is contained in B, the common part will be equal to the smaller set B. So we can easily we can say that A intersection B is equal to B. In part D, is A union B is equal to A? Since A is the bigger set and B the smaller set contained in A, if we combine all the elements of A and B, we still get all the elements of A, nothing more, nothing less. So A union B is equal to the bigger set A. And in E part, we have to draw a Venn diagram for the two sets A and B. First, we will draw the biggest set A containing the letters I, M, P, and S. Let us draw it. Okay. Now we will draw a set B also. Set B is contained in A because it has only one element that is contained in A. So we will make the set B inside the set A so that it contains contains the element S. In question number 3, we have been given a universal set which contains which is a set of elements x such that each x is a positive integer not more than 25. All positive integers which are equal to less than 25 will come in this set, and set A is an even number. So whatever set A is, it should come from the universal set. No element in set A is going to come out of the universal set, and set B is a set of factors of 18. All right. So in A part, we have to list the elements of the three sets. So first of all, the universal set is simply the first 25 integers which are not more than 25 and they are positive. So we will not include 0. 0 is not a positive number. It's neither negative nor positive. So we will start from 1 and write all the integers from 1 till 25. We will use dot 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 so that we don't have to write all the integers. They are understood to be included between the integers between 4 and 25. In B part, okay, let's list the elements of the set A and B also. The set A contains even numbers. So even numbers in the universal set are 2, 4, 6, 8, etc. till 24. So we will list all these numbers. And in set B, the elements are the factor of 18, right? So what are the factors of 8? Factors of 18 are 1, 18, right? Then 2 into 9 is 18, 2 and 9 are factors. Then 3 into 6 is 18, 3 and 6 are factors. So we will write all these numbers in order to form a set B which contains a factor of 18. So these factors are 1, 2, 3, 6, 9 and 18. All the factors of 18 we have written in set B. In B part, we have to draw a Venn diagram of the three sets. First of all, we will draw the universal set, a big rectangle which is drawn by this epsilon type of symbol. This is the universal set. All of the sets will be lying in this inside this universal set. Okay, let's make set A and B, then we will write the elements. Okay, first of all, see 1. 1 is in the universal set and set B. So it will not come in A, but it will come in B. So it will come here. Next element is 2. 2 is an even number. It will come in A, but and also it is a factor of 18. It will come in B, and it is already in universal set, so it will come in the common part. Similarly, we will write all the elements one by one. The common elements will come in the intersection part, and the numbers which are even and but not factors of 18 will come outside B but inside A, and then numbers which are odd will come outside of both of the numbers, because the numbers which are odd cannot come inside A, or cannot come inside A, but the numbers which are odd but factors of 18 can come inside set B. For example, 3 and 9, they are odd but factors of 18, they will come inside B but outside the set A. So this way we'll write all the numbers. 16 being even number but not a factor of 18 will come outside B, and 17 being an odd number and not a factor of 18 will come outside of set A and B. And 18 is a factor of 18 and an even number, so will come in both of the sets. So 19, and we will write all the numbers. So this way we have completed our Venn diagram. In part C, we have to write A union B and A intersection from the Venn diagram. In A union B, we will simply combine all the elements of set A and set B. So we will write all the elements in order. From the Venn diagram, we can see easily which elements are in A and B. So we will write all these elements in order to write the set element to write the set A union B, and then we have to write the set A intersection B. Intersection means the common elements, the elements which are contained both in A and B. These are only three elements, 2, 6, and 18. So we will write intersection B is equal to 2, 6, and 18.